electronics techie. Today our topic is about logic gates. In every digital electronics, the logic gates are the basic building blocks for all the things. So must and should you know about these logic gates. Let's look into the what are the logic gates and what is the functionality, what are the truth tables you have to see in this video. If you have any doubts, you can comment on comment section like that. I will give reply. So first of all, you have to know what are the logic gates, what are the types of logic gates like that. The logic gates are mainly three types like basic gates, basic gates, whereas second one as universal gates, where third one as special or not other gates, special gates or other gates like that. Basic gates are again basic gates. What are the basic gates? NOT gate, AND gate, OR gate. Whereas the universal gates are two, NAND gate and another one is NOR gate. Whereas other gates are XOR, XNOR. So these are the different types of logic gates. In this video you can discuss about every logic gates in detail. So first we can consider as NOT gate. NOT gate is nothing but inverted. Whatever the input you give, the inverted output will become the output. So NOT gate symbol is like this. If you give input as A, the output will become A bar, means bar or complement. It can represent the inverted output or complementary output like that. So I have to draw truth table for this. Only one input A and the output will be A bar. It is input, it is output. If you give input as 0, you get output as 1. If you give input as 1, you get output as 0. So this is the truth table of NOT gate. NOT gate is used for inverted output like that. So it is the a initial gate for you can build any gate from this also. So you can discuss later. So now move into the AND gate. AND gate symbol is like this. It contains two input I1 and I2. It is the output, only one output. This expression is like product I1 dot I2, means whatever the inputs you give, it get product and then get the output like that. So you have to draw the truth table, then you can understand in better way. I1, I2, whereas output expression is I1 dot I2. Two inputs means there is a 4 combination 0 0 0 1 1 0 1 1. For 0 0, 0 into 0 0, 0 into 1 0, 1 into 0 0, 1 into 1 1. Means whatever the input either I1 or I2, one of the input is 0, then the output will become 0. Here you can see that any one of the input 0 means it is 0. Here I1 or I2, I1 is 0, so it is 0. So I2 is 0, 0. If both are high, then it will be logic 1. Logic 1 are high, it represents 1. Whereas logic 0, low, these are represent to 0. So like this NAND AND gate is represented like this. Let's move on to OR gate. OR gate symbol is seems like this. Sorry, I will. So OR gate symbol is like this. Two inputs I1 and I2, and the output will be. Here the output expression is like addition, I1 plus I2 like that. You can draw truth table for this. I1, I2, output. Output expression is the sum of the two inputs. Means two inputs means there are again 4 combinations. So 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, 1. So like this, whatever the here by OR gate we can say that if any one of the input is 1, then the output will become 0, otherwise it is 0. So here see I1, I2 is 1, so become output will be 1. If I1 is I1 or I2, here I1 is 1, so we get output as 1. Any one of the input is 1, then we get the output as 1, otherwise we get as a 0. So in NAND gate what you observe, if any one of the input is 0, you get output as 0. In OR gate, if any one of the input is 1, we get output as 1, otherwise 0. So you can see the difference like this. These are about the OR gate. Let's move into the universal gates. That is first is NAND gate. Why you call it as NAND gates? You can try to answer these in comment section. I will say why you call these NAND and NOR as universal gates. I say detailed information in next video. So try to answer these my question in comment section. Why you call as NAND and NOR only universal gates? Why not NAND and OR gates? Just think. And there is so many technology like that. You have to search and you have to know and then comment. Otherwise I say in next video like that. Okay, just now move into the NAND gate. NAND gate symbol is like this. There are also two inputs. So differently you can consider as input as A, B. Whatever the inputs you can represent it with any alphabet like that. No worry about this. But according to your inputs, what you take, you can draw the truth table like that. If you take I1, I2, then you can write I1, I2 here. If you take AB, you can write like that. NAND gate is nothing but inverted of AND gate. Means whatever the truth table you draw in AND gate, this complementary will be the NAND gate. So what means 0 complement is 1, 0 complement is 1, 0 complement is 1, 1 complement is 0. So this is the truth table of NAND gate. Whatever the AND gate truth table, it is the inverted of AND gate. Means if you consider these AND gate, you can put it as NOT gate. Means we know that NOT gate is invert the input whatever you give like that. So it is the NAND gate. So 0, 0, 0, 1, 1, 0, 1, 1. First I write AND gate, then I write NAND gate, then you easily understand NAND. So first AND gate means what you say, if any one of the input is 0, then the output will be 0 like that. So what is the inverted of the AND gate? What is NAND? Inverted of the AND gate. So you can write 0 inverted is 1, 0 opposite is 1, 0 opposite is 1, 1 opposite 0. So this is the truth table of NAND gate. 1, 1, 1, 0. For the inputs 0, 0, 0, 1, 1, 0, 1, 1. This is the truth table for NAND gate. Whereas these are the inputs, whereas these are the outputs. So this is about the NAND gate. Just move into the NOR gate. So now I think you get the idea what is NOR gate like that. It is also same as NAND gate, but NAND gate is the inverted output of AND gate, but whereas NOR is the inverted output of the OR gate. So its symbols like this. This dot symbol is represented like it is a NOT gate like that. NOR gate symbol is it's like this only. I just explained you. A, B, two inputs and whereas output means whatever the bubble here, it represents the NOT gate. It is the OR gate. So OR plus NOT is equal to NOR gate. So A, B and output. How the truth table you can draw like this. So here also I draw A, B. First I draw for output for OR gate and the output for NOR gate. Then you can simply understand about this 0, 0, 0, 1, 1, 0. For two inputs you get 4 combinations. 2 square like that 4. Whereas for 3 combination we get 8 combinations. So you can like this, you can say that. So 2 inputs 2 square means 4 combinations you get 0, 0, 0, 1, 1, 0, 1, 1. OR gate means what you say about OR gate, if any one of the input is high, then the output will become high. So here in this one there is at least one high input like that, that's why the output will be high. NOR gate, what you say about NOR gate, the inverted output of the OR gate will be the NOR gate. So you can write it as inverted. 0 means 1, 1 means 0, 0, 0 like that. So what is the truth table for NOR gate? 1, 0, 0. For whatever the OR gate values, it can be inverted in the NOR gate. So it is about the NOR gate. Then you can discuss about special gates, whereas XOR. For XOR gate, its symbol seems like this. So you can draw like this. Its symbol seems like this. A, B as the input, whereas the output, one input and as well as the two outputs. Here the output expression is like this. Sorry. output expression is like this: A bar B plus A B bar. So you can now draw the truth table for this, then you can understand. A B output. Output expression is A bar B plus A B bar, means A bar, whatever the input A, it can be inverted and product with B plus A into A, means whatever the input 1 will be the same, but whatever the second input will be inverted, then the both results will be added. So 0 0 0 1 1 0 1 1. First consider 0 0. So again I can write another expression for that 0 0 combinations. I can do detailed information here. A bar B plus A B bar. So first it is A, it is B. A bar means 1 dot, B means 0 plus A means 0 dot, B bar means 1. 1 into 0 0 plus 0 dot 0, 0 dot 1 0. So now you can add 0 plus 0 equal to 0. So the first combination output will be 0. Then again take 0 1. So now AB has 0 1. Again same expression, A bar B plus A B bar. Means A bar means 0 bar means 1. Means bar represent the inverted output. 0 means 1, 1 for 0. Here A is 0, so you can write as 1 into B. B as it is 1 plus A 0 into B bar means 1 output 0. So 1 into 1 1 plus 0 into 0 0. 1 plus 0 equal to 1. So you can write this as 1. For that, like this we can do all the remaining 2. We can get like this. For sorry, here I do some mistake. The last combination is 1 1 like that. From this XOR gate we can say that if the two inputs is equal, means either 0 0 or 1 1, only for same inputs, then you get output as logic 0. Whereas different inputs we can consider either 0 or 1 or 1 0, the output will be logic high. We can remember like this in simple way, but whatever how you get these expression or these truth table, means this is the proof for you. So whatever the input combinations is equal for 0 0 combination or 1 1 combination, whatever the inputs of two inputs for the XOR gate, then the output will be logic 0, otherwise logic high. So like that you can remember. For detailed explanation you can use formula also. So nothing, not problem about that. We can represent this XOR as these expression is simply represented like A XOR B like this. So this inside circle you can represent as plus, it can be represented as XOR symbol like that. So you can call it as A XOR B. You can write it also like this. So now let's move into the XNOR gate. XNOR gate symbol is like this. Means two inputs A B. Here is the output for this. So here you can observe, I already said this bubble represent NOT gate, whereas it is XOR gate. So whatever the output of XOR gate is inverted, then it will be the XOR gate. So from this what you say, you can simply write an example for this. So first you can write the truth table for XOR gate, then you can simply draw for XNOR. So two inputs means 4 combinations. What I say, whatever the input same, then we can get as logic 0, where otherwise we can get logic 1. So XNOR means it is completely inverted of XOR gate. So outputs, these are outputs. So 0 means 1, 1 means 0, 1 means 0, 0 means 1. Then what is the output expression for these? Output expression for these is A bar B plus A B bar whole complement. Means whatever the input, whatever the output of XOR gate is NOT gate, is NOT means inverted, then we can say it as a XNOR gate. We can represent it with like this. XNOR is represented like this. So by the symbol you can represent it as A XOR B like that. I think everything is detailed. In this we discuss about AND gate, OR gate. Firstly we discuss about NOT gate. These are the basic gates, whereas NAND gate, NOR gate, these are the universal gates we discuss, and other special gates are XOR and XNOR. I think you understand about this. If you have any doubts you can comment. Thank you so much. Thanks a lot.